In response to the growing use of AI-related technologies across various technical fields, the JPO has added examination case examples for AI-related technologies to ensure a consistent approach to determining patentability, regardless of the specific field of technology. In this video, we will introduce examination case examples for AI-related technologies. This video consists of 4 chapters. Chapter 1 covers requirement for description and claims. Chapter 2 covers novelty. Chapter 3 covers inventive step. Chapter 4 covers eligibility for patent. Let's begin with requirement for description and claims. Determination on the enablement requirement for inventions of AI-related technologies is conducted in accordance with the examination guidelines. The enablement requirement refers to the requirement that the statement in the description must be clear and sufficient to enable a person ordinarily skilled in the art of the invention to carry out the invention. The examiner determines whether the statement in the description satisfies the enablement requirement, based on the category of the claimed invention. For an invention of a product, the enablement requirement is to ensure both the capability of making the product and the capability of using the product. For an invention of a process, the enablement requirement is to ensure the capability of using the process. For an invention of a process for producing a product, the enablement requirement is to ensure the capability of making the product by using the process. Next, we will look at how the support requirement is determined for inventions of AI-related technologies. This determination is also conducted in accordance with the examination guidelines. The support requirement refers to the requirement that the scope of a claimed invention should not exceed the extent of disclosure in the description. This is because, if an invention not stated in the description is included in the scope of the claims, it would result in granting rights for an invention that has not been disclosed to the public. Whether the statement in the claims satisfies the support requirement is determined by comparing and considering the claimed invention and the matter that is stated as an invention in the description. In performing this comparison, the examiner considers a substantial correspondence between the claimed invention and the matter that is stated as the invention in the description, without sticking to the consistency of wordings. The consideration of the substantial correspondence done by the examiner is to examine whether or not the claimed invention exceeds the extent of disclosure in the description to which a person skilled in the art would recognize that a problem to be solved by the invention would actually be solved. If it is determined that the claimed invention exceeds the extent of disclosure in the description, the claimed invention and the matter that is stated as the invention do not substantially correspond with each other, and thus, the statement in the claims does not satisfy the support requirement. This is a list of case examples prepared by the JPO regarding the requirements for description and claims for AI-related inventions. The cases outlined in red were added in 2024. In the field of AI-related inventions, the following cases are examples that satisfy the requirements. 1. Case in which it can be presumed that there is a correlation between multiple types of data included in training data in view of a common general technical knowledge at the time of filing. 2. Case in which a correlation between multiple types of data included in training data is supported by explanations and statistical information stated in the description, etc. 3. Case in which a correlation between multiple types of data included in training data is supported by the performance evaluation of the artificial intelligence model actually created. In addition, there are case examples involving inventions of a product that are presumed to have a certain function by AI, and inventions that create training data. For each perspective, we have listed cases that satisfy the requirements and those that do not. Here, from among various case examples, we will introduce the case of a body weight estimation system. First, we will explain the body weight estimation system as defined in Claim 1. According to Claim 1, feature values representing face images as well as actual measured values of the body height and the body weight of people are used as training data. The system has a means for generating an estimation model that estimates the body weight of a person based on such value-related data through machine learning. Moreover, it has a means for receiving input of a face image and the body height of a person, as well as a means for obtaining a feature value representing the face shape of the person through analysis of the received face image. Furthermore, it has a processing means to output an estimated value of body weight based on the input data. And Claim 2 defines that the feature value representing a face shape is a face outline angle. Here, the description states that an angle indicated in red, which is defined as a face outline angle, is used as a feature value representing the face shape of a person. It is also stated that there is a statistically significant correlation between a cosine of a face outline angle and BMI defined as body weight divided by the square of body height of a person. However, the description does not include any certain relationship, such as a correlation, between a feature value representing a face shape other than a face outline angle and the person's body height, weight, or BMI based on these. And, as a premise, it is assumed that, even in view of common general technical knowledge at the time of filing, a person skilled in the art cannot presume any certain relationship between such values. Therefore, for Claim 1, the support and enablement requirements are not satisfied. On the other hand, for Claim 2, the support and enablement requirements are satisfied. This is because the description indicates that there is a statistically significant correlation among the training data defined in Claim 2. In Chapter 2, we will look at Novelty. According to Article 29 of the Patent Act, a person that creates an invention with industrial applicability may obtain a patent for that invention, unless the invention is as follows. 1. Inventions that were publicly known in Japan or a foreign country prior to the filing. 2. Inventions that were publicly worked in Japan or a foreign country prior to the filing. Or 3. Inventions that were described in a distributed publication or were made publicly available through an electric telecommunications line in Japan or a foreign country prior to the filing. This provision reflects the idea that since the purpose of the patent system is to grant an exclusive right in exchange for the publication of an invention, inventions deserving patents should be novel. As a result of comparing the claimed invention with the cited invention, if differences are identified, the examiner determines that the claimed invention has novelty. On the other hand, if no differences are identified, the examiner determines that the claimed invention lacks novelty. Next, we will explain novelty in subcombination inventions. In the case of an invention of the overall apparatus made of a combination of two or more devices, or an invention of a manufacturing method formed of a combination of two or more processes, combination, a subcombination invention refers to an invention of each device or each process of the combination. IoT-related technologies are generally realized as a system where several devices and terminals are connected through a network, and therefore a part of the system may be applied for a patent as a subcombination invention. Novelty of subcombination inventions of IoT-related technologies is determined in the same way as that of subcombination inventions in other technical fields. From here, we will explain how subcombination inventions are specified for novelty determination, based on the examination guidelines. When specifying the claimed invention, the examiner should consider elements relevant to another subcombination stated in the claim and not ignore them in specifying the claimed invention. The examiner should also understand the role which the elements have in specifying the subcombination invention from the aspect of its structure, function, etc., when he or she specifies the claimed subcombination invention. In this regard, the examiner should take into account the statements in the description and drawings as well as the common general knowledge at the time of filing. Let's look at some case examples related to novelty. This is an invention involving a robotic apparatus. In this example, both Claim 1 of the present invention and the cited invention specify the following elements: at least one kind of sensor for detecting the object, a transmission section for transmitting a query to a server in order to acquire information on the object based on an output of the sensor, a reception section for receiving response information answering the query from the server, and a control section storing a program which controls the operation of the robot apparatus on the basis of the received response information. Then, in the present invention, the response information contains the attribute information and the unique identification information of each object specified by the server. In contrast, in the cited invention, the response information is the information on the type of object specified by the server. Claim 1 of the present invention is determined to have novelty in comparison with the cited invention, which will be explained here. As previously mentioned, Claim 1 recites a feature related to the server. The other subcombination, namely, the response information, contains the attribute information and the unique identification information of each object specified by the server. With respect to the response information, Claim 1 also specifies that the robot apparatus has a control section storing a program which controls the operation of the robot apparatus on the basis of the received response information. Therefore, the robot apparatus of the invention of Claim 1 has a control section storing a program which controls the operation of the robot apparatus on the basis of the attribute information and the unique identification information of each of the object, and performs the operation through the control section in response to the attribute information and the unique identification information of each object. In contrast, in the cited invention, the response information is the information on the type of object specified by the server. Therefore, the robot apparatus only has a control section with a program which controls the operation of the robot apparatus on the basis of the information on the type of the object, vis-a-vis the response information, and does not operate in response to the attribute information and the unique identification information of the object. Thus, the robot apparatus of the invention of Claim 1 includes a different program and performs different operations from the robot apparatus of the cited invention. In conclusion, since there are differences between the invention of Claim 1 and the cited invention, the invention of Claim 1 is determined to have novelty. Next, we will present the determination of novelty with respect to the same cited invention, in relation to a claimed invention involving a similar robot device, where the response information differs from the previous example. In the present Claim 1, it is specified that the response information is the information on the type of the object specified by the server on the basis of information received via a network from a production facility of the object. In this example, the invention of Claim 1 is determined to lack novelty, which will be explained here. The robot apparatus according to Claim 1 is a subcombination, which is a part of a combination of the robot apparatus and the server. Claim 1 on the robot apparatus recites a feature related to the server. The other subcombination, namely, the response information, is the information on the type of the object specified by the server on the basis of information received via a network from a production facility of the object. However, the portion of on the basis of information received via a network from a production facility of the object only describes the source from which the server, separate from the robot apparatus, obtains information for specifying response information. This does not make any difference in the program of the robot apparatus itself, and does not serve to specify a structure, a function, etc., of the robot apparatus. Consequently, there is no difference between the invention of Claim 1 and the cited invention. As a result, the invention of Claim 1 is determined to lack novelty. In Chapter 3, we will look at Inventive Step. Article 29, Paragraph 2 of the Patent Act states that a patent shall not be granted for an invention where, prior to the filing of the patent application, a person ordinarily skilled in the art of the invention would have easily been able to make the invention based on the prior art. This is because granting patent rights for inventions that could have easily been made does not promote the progress of the technology but rather prevents it. A person ordinarily skilled in the art of the invention, also known as a person skilled in the art, means a hypothetical person who meets all the following conditions 1 to 4. 1. Having the common general knowledge in the technical field of the claimed invention at the time of filing. 2. Being able to use ordinary technical means for research and development, including document analysis, experiment, technical analysis, manufacture, etc. 3. Being able to exercise ordinary creativity in selecting materials and modifying designs, and 4. Being able to comprehend all matters in the state of the art in the technical field of the claimed invention at the time of filing, and comprehend all technical matters in the field relevant to problems to be solved by the invention. In this context, the state of the art includes not only the prior art but also common general knowledge, technical findings and other technical knowledge. In some cases, it is appropriate to consider a person skilled in the art to be a team of experts in several technical fields rather than an individual person. The examiner determines whether the claimed invention involves an inventive step by considering whether or not it is possible to reason that a person skilled in the art would easily arrive at the claimed invention from the primary prior art. Whether or not a person skilled in the art would easily arrive at the claimed invention should be determined by comprehensively assessing various factors in support of the non-existence or existence of an inventive step. The examiner therefore attempts the reasoning by assessing these factors legally. The JPO refers to this method as MFR. There are the following 3 factors in support of the non-existence of an inventive step. First, if the secondary prior art B is applied to the primary prior art A, and then the resultant A plus B is equivalent to the claimed invention, the motivation to attempt this application is a factor in support of the non-existence of an inventive step. Here, it is determined whether or not there is motivation for applying the secondary prior art to the primary prior art by comprehensively considering points 1 to 4 displayed on the screen. The examiner should note that it is not always possible to determine whether there is motivation by paying attention to only one of these points. Second, if a person skilled in the art would arrive at the claimed elements that correspond to the differences between the claimed invention and the primary prior art starting from the primary prior art through mere design variation etc., there is a factor in support of the non-existence of an inventive step. Third, mere aggregation of prior art is a factor in support of the non-existence of an inventive step. On the other hand, there are the following 2 factors in support of the existence of an inventive step. The first factor is the presence of advantageous effects over the prior art. The second factor is the presence of factors which obstruct application of the secondary prior art to the primary prior art. This is a list of case examples prepared by the JPO regarding the inventive step for AI-related inventions. First, we will introduce a case example of an automatic response generator for customer service centers. This example was determined to lack an inventive step because it is a simple systematization of human tasks using generative AI. The invention of Claim 1 is an automatic response generator for a customer service center for receiving text of an inquiry about a financial product from an inquirer and automatically generating a response text, generated by inputting the question text into large language models. In contrast, the cited invention 1 is a method of preparing a response text for a received text of an inquiry about a financial product from an inquirer, and preparing a response text by a customer service center employee, prepared by searching a database of accumulated examples of past inquiries and referring to examples matching the question text. While the invention of Claim 1 is an automatic response generator for a customer service center that receives a question text and generates a response text through large language models, the cited invention is a method for preparing a response text by searching a database. This is the difference between the two inventions. Now, please take a look at the gray area on the screen. In the technical field of information processing, it is assumed that the process of inputting question texts into large language models to obtain response texts is commonly used to improve the efficiency of human tasks. In many business fields, including customer service, it is a self-evident problem that a person skilled in the art normally takes into consideration efficiency improvement by automating human tasks with computers. And it would also be taken into consideration in the cited invention 1. Given this, it is easily conceivable for a person skilled in the art to provide the configuration corresponding to the difference by applying the previously mentioned commonly used art to the cited invention 1. In conclusion, the invention of Claim 1 is determined to lack an inventive step. Next, as the second case example related to the determination of inventive step, we will introduce an invention involving an estimation system of hydroelectric generating capacity. The invention of Claim 1 is an estimation system of a hydroelectric power generating capacity of a dam that implements a neural network built by means of an information processor. The system comprises the neural network having an input layer and an output layer, in which an input data to the input layer containing a precipitation amount of the upper stream of a river, a water flow rate of the upper stream of the river, and a water inflow rate into a dam during a predetermined period between a reference time and a predetermined time before the reference time, and an output data from the output layer containing a hydroelectric power generating capacity in the future after the reference time. Moreover, the system has a machine learning unit that trains the neural network using a training data corresponding to actual values of the input data and the output data. Furthermore, the system has an estimation unit that inputs data to the neural network that has been trained by the machine learning unit with the current time set as the reference time, and then calculates an estimated value of a future hydroelectric power generating capacity based on the output data of which reference time is the current time. And Claim 2 defines that in the estimation system of a hydroelectric power generating capacity as in Claim 1, the input data to the input layer further contains a temperature of the upper stream of the river during the predetermined period between the reference time and the predetermined time before the reference time. Next, cited invention 1 will be explained. This is an estimation system of a hydroelectric power generating capacity of a dam that carries out a multiple regression analysis by an information processor. The system comprises a regression equation model, in which explanatory variables are a precipitation amount of the upper stream of a river, a water flow rate of the upper stream of the river, and a water inflow rate into a dam during a predetermined period between a reference time and a predetermined time before the reference time, and an objective variable is a hydroelectric power generating capacity in the future after the reference time. Moreover, the system has an analysis unit that calculates a partial regression coefficient of the regression equation model based on actual values corresponding to the explanatory variables and the objective variable. Furthermore, the system has an estimation unit that, into the regression equation model to which the partial regression coefficient that has been calculated by the analysis unit is set, inputs data of the explanatory variables with setting a current time as the reference time, and then, calculates an estimated value of a future hydroelectric power generating capacity based on an output data from the objective variable setting a current time as the reference time. Thus, the invention of Claim 1 realizes an estimation of a hydroelectric power generating capacity by means of a neural network having an input layer and output layer. Meanwhile, cited invention 1 realizes an estimation of a hydroelectric power generating capacity by means of a regression equation model. In this respect, the two inventions differ. However, it is well known that an estimation process of an output in the future is carried out based on an input of time series data in the past, by using a trained neural network which has been trained with training data containing an input of time series data in the past and a certain output in the future. And, cited invention 1, and the well-known art share a commonality in estimating a certain output in the future based on an input of time series data in the past, with reference to a correlation among data. Therefore, a person skilled in the art could easily derive a configuration that enables estimation of a hydroelectric power generating capacity, by applying the well-known art to cited invention 1, and adopting a trained neural network in substitution of a regression equation model. Further, a person skilled in the art would expect the effect of the invention of Claim 1, and there is no obstructive factor found in applying the well-known art to cited invention 1. In conclusion, the invention of Claim 1 is determined to lack an inventive step. On the other hand, when comparing the invention of Claim 2 with cited invention 1, the invention of Claim 2 contains an input data into an input layer, a temperature of the upper stream of the river, whereas cited invention 1 does not have such a configuration. In this respect, the two inventions differ further. Here, there is no prior art found disclosing such use of the temperature of the upper stream of the river for estimation of a hydroelectric power generating capacity. Therefore, it is not common general technical knowledge that there is a correlation between a temperature and a hydroelectric power generating capacity. And, in the invention of Claim 2, it is indicated that the use of the upper stream temperature enables a highly accurate estimation of a hydroelectric power generating capacity. It is a significant effect that a person skilled in the art cannot expect from cited invention 1. In conclusion, the invention of Claim 2 is determined to have an inventive step. Lastly, we will look at eligibility for patent. In Article 2, Paragraph 1 of the Patent Act, an invention is defined as a highly advanced creation of technical ideas utilizing a law of nature. Here, we will explain this definition. First, a statutory invention shall utilize a law of nature. Therefore, not only laws of nature themselves, but also those that are contrary to a law of nature or arbitrary arrangements that do not utilize a law of nature, are not considered as a statutory invention. Next, a statutory invention shall be a technical idea. Therefore, for example, personal skills, that is to say, those that are acquired through personal experience and cannot be shared with others as a knowledge due to lack of objectivity, are not considered as a statutory invention. Furthermore, a statutory invention shall be a creation. Therefore, for example, mere discoveries of microorganisms in nature, for which an inventor does not create any technical idea with intention, are not considered as a statutory invention. On the other hand, if microorganisms have been isolated artificially from their surroundings, those are creations and considered as statutory inventions. Additionally, the term highly advanced in the definition of a statutory invention mainly serves to differentiate the invention from a device under the Utility Model Act. Thus, it is not necessary to consider it to determine whether the application falls under a statutory invention. With the rise of AI and other emerging technologies, software-related inventions involving AI-related technologies are now being created across a wide range of technical fields. As a result, there has been a growing demand from examiners and users in various fields for a clear understanding of the fundamental ideas regarding the eligibility for patent and other requirements for software-related inventions. In response to this situation, the JPO has clarified the examination guidelines regarding the eligibility for patent of software-related inventions, without changing the fundamental ideas. The process of determining whether a claimed software-related invention is a creation of a technical idea utilizing a law of nature is as follows. First, based on the general approach to determining eligibility for patent as stated in the examination guidelines, the examiner reviews whether or not the claimed software-related invention is a creation of a technical idea utilizing a law of nature. If, based on the general approach, a determination is made on whether or not the claimed software-related invention is a creation of a technical idea utilizing a law of nature, the examiner does not proceed to the subsequent step involving the idea based on the standpoint of software. If not, the examiner shall make a determination according to the idea based on the standpoint of software. When making the determination, the examiner reviews whether or not the claimed invention as a whole is a creation of a technical idea utilizing a law of nature, irrespective of part of matters specifying the invention in the claims. From here, we will explain the idea based on the standpoint of software, previously mentioned. When for software of a software-related invention, information processing by the software is concretely realized by using hardware resources, the software is a creation of a technical idea utilizing the laws of nature. Information processing by the software is concretely realized by using hardware resources means that a specific information processor or an operation method thereof depending on intended use is constructed through cooperation of the software and the hardware resources. Note that the claims do not require the hardware resources to be specified in detail. Moreover, for an information processor which operates in cooperation with software and an operation method thereof, as well as a computer-readable recording medium in which the software is recorded, if the software satisfies the requirement of cooperation above, it is a creation of a technical idea utilizing the laws of nature. As a supplement, we will provide points to note when referring to the case examples provided in the examination handbook. In the examination handbook, there are cases that only the determination of the requirement of Step 2 is mentioned. However, in practice, prior to the determination of the requirement, a determination whether or not it is a creation of a technical idea utilizing the law of nature in the examination guidelines has been performed. As a case example related to the eligibility for patent, we will introduce an example concerning sugar content data of apples and a method for predicting sugar content data of apples. The invention of Claim 1 is sugar content data of pre-harvest apples on trees measured by a portable sugar content sensor for apples which performs reflective near-infrared spectroscopic analyses. And the invention of Claim 2 is the sugar content data of apples as described in Claim 1, received by a receiving unit of a server and stored in a memory unit of the server. In conclusion, the invention of Claim 1 or 2 is determined not to fall under a statutory invention. The reason is that the apple sugar content data described in Claim 1 or 2 is mere presentation of information. On the other hand, the invention of Claim 3 is a method for predicting sugar content data of apples and comprises the steps illustrated in the diagram on the screen. The method comprises a step in which an analyzing unit of the server analyzes the relationship between sugar content data of pre-harvest apples for specified periods and data on meteorological conditions, and sugar content data of apples at the time of their shipping, based on past performance, a step in which the receiving unit of the server receives the sugar content data of apples for specified periods as described in Claim 1, and a step in which a prediction unit of the server predicts and outputs sugar content data of apples at the time of future shipping using the received sugar content data of apples for specified periods and data on past and future meteorological conditions as inputs, based on the said analyzed relationships. As shown in the steps just mentioned, the invention of Claim 3 is what concretely performs information processing based on the technical properties, such as chemical or biological properties, of apples. In conclusion, the invention of Claim 3 is determined to fall under a statutory invention. That concludes the explanation in this video. Thank you for your attention.